In our next section on geometric mean, we're going to have to put radicals in their simplest form. So on this set of notes, we're going to go through 4 different radical problems and talk about how you can reduce radicals and put them in their simplest form. So let's say that we have the square root of 50 and I want to reduce the square root of 50. What I want to do first is I want to figure out all the different factors of 50. So I know that 50 can come from 5 times 1. 50 can come from 10 times 5. 50 can come from 25 times 2. Out of all of these numbers, I want to look for the numbers that have the perfect, or that is a perfect square, the one number that is a perfect square. In this case, that number is 25. So what I'm going to do to the 50 is put it, instead of just in one radical, put it into 2 radicals, and both the radicals are going to be numbers that are going to factor from 50, one of them being the perfect square. Now, with 25 being a perfect square, the square root of 25 is 5. So now that can turn into 5. This will remain the square root of 2, and this will be your final answer. So let's look at number 2. You can do this problem 2 different ways. The first way is if you multiply 2 radicals together, like the square root of 2 times the square root of 8, you're actually saying the square root of 2 times 8, which is the square root of 16. Okay, then the square root of 16, of course, is 4. Now another way you can do this is you can actually separate, go ahead and rewrite it. The square root of 2 cannot be simplified any more than it is, because there are no other factors besides 2 and 1 that multiply together to make 2. But I know that the square root of 8 can be simplified a little bit more. So what I'm going to do is I'm going to go ahead and bring down this square root of 2 and not change it. But the square root of 8 can be separated into the square root of 4 times the square root of 2. So now what I'm going to do is go ahead and continue to bring down the square root of 2. The square root of 4 is 2, since 4 is a perfect square, and then bring down this square root of 2. Now the rule is, if you have 2 radicals that contain the same number, the square root of 2 times the square root of 2, the product of those 2 radicals is the number inside of the radical. The square root of 2 times the square root of 2 is 2. And 2 times 2, which is carried down here, equals 4. I know it is very obvious that this way is easier, okay, just to multiply the numbers together and create a perfect square. Okay, but I just wanted to show you how you can separate it and still get the same exact answer. Alright, the next thing we're going to do is look at 294, the square root of 294, divided by the square root of 3. The square root of 294 divided by the square root of 3. Now, if I'm going to write this radical or rewrite it, I'm going to rewrite this as just one straight up fraction, or radical of 294 over 3. Just like I combine my multiplication over here and put them both in one radical, you can do the same thing with your division. Put 294 and 3 in one fraction under one radical. Now 3 does go into 294, so I'm going to go ahead and find that quotient there and do 294 divided by 3, which is 98. Now the square root of 98 is the number that I want to simplify. And I think of all the numbers that would multiply together to make 98, one of them being a perfect square. So I'm going to go through all the perfect squares. I have 4, 98, or 4 going into 98, 9 going into 98, 16 going into 98, 25 going into 98, and keep going. And eventually you're going to find that 98 is the product of 49 and 2. 49 times 2 gives me 98. The square root of 49 is 7. The square root of 2 will remain as the square root of 2, and that'll be your answer. Anytime you have the square root of 2, or the square root of 3, or the square root of 7, which they all have in common that the number inside a radical is a prime number. If the number inside the radical is a prime number, then you will be stopping at that point. There was no simplifying there. Now there are some numbers that are not prime numbers, such as the square root of 10. The square root of 10 cannot be simplified because it does not have any factors that are perfect squares. So those are the two ways you will know whether or not a number can continue to be simplified. Then finally in number 4, I have the square root of 4 over the square root of 4 over 3. Now this time I'm actually going to separate. Since 3 does not go in directly in the 4, I'm going to make this two separate radicals, one on top of the other. Sorry, I need to move this down. One on top of the other, where I add the square root of 4 over the square root of 3. Again, I'm doing it this way because 3 is not a factor of 4. Now, if you ever have a radical in your denominator, you need to move it. A simplified radical does not have a radical in your denominator. So you're going to multiply the top and the bottom by the square root of 3. It's like multiplying by 1. The square root of 3 over the square root of 3 is 1. That's why it is legal to multiply the numerator and the denominator by something as long as that number is the same exact thing. And you multiply across. So 4 times 3 is 12. This gives me the square root of 12. Okay, and then I have the square root of 3 times the square root of 3, which is 3. Now what I want to do is take that square root of 12 over 3 and reduce that square root of 12. Simplify it. That 12 can turn into 4 and 3, since 4 is a perfect square, which then turns out to be 2 times the square root of 3 over 3. So that is the simplified version of the square root of 4 over 3. In class, we're going to be doing about 24 problems that are dealing with the simplifying radicals. And again, we are doing this because of the fact that the geometric mean that we're going to be covering in class, we're going to have to be reducing and simplifying radicals. So that's why it's important that you know how to do this concept.